Hello, class. This week's article, I want to talk about our self-driving labs. And I'm going to send the link. I know I normally send an article, but the link, and I checked it with a different browser, and you don't need to have a membership or anything. It's free and open to the public, because you can see these animations. And this is kind of cool. Like, have you ever seen the music video for Postal Service's Such Great Heights? It kind of reminds me of that. You have these robots doing all these things. And this is talking about the future, where things are going. And I think about this a lot, like where society is going and how things are going to change. And I wonder about also with my son. I wonder about with education, how things are going and how things are changing. And as you know, for this class, we do online labs. And I am very, very much in favor of online labs. And for one of the reasons is because of articles like this. Though I get it that people need to learn how to do like how titration works and what it means. Like, truth of the matter is, no one does titrations anymore. Robots do it. Like, why would we pay someone? Like, why would we take a chemist and then or get someone and train them and then have to pay them? I mean, it's going to be somewhere between $100,000 and $150,000 a year to do that. And of course, this person's only going to work 40 hours a week. So when I say it's going to cost $100,000 to $150,000, because that's what If you look at medical, if you look at retirement, if you look at the overhead for having someone, all the taxes involved in that, that's expensive. And meanwhile, this article mentions that one of these robotic arms costs about $2,000, and you have an AI-driven machine. For 100, we'll go high end, $150,000. How many robot arms? How much computing power do you need for this? And then you have these robots that work, and they're going to work on the order of, they're going to work all the time. It's not just 40 hours a week. It's constant with very little downtime. So, but that's just the mechanical nature of things. And like the low skilled labor jobs are kind of going away, right? They've already, at least in the high cost labor part of the United States, it's been outsourced to other countries. First of all, secondly, it's just being overcome by robots and AI. And AI's we're not there. We're not the same as humans, but AI is pretty impressive. I used AI to help me write a grant proposal, and I haven't heard back from it, but I hope I get it. It was a $2 million grant, and I worked with AI to get it, but it wasn't. I didn't just I didn't just let AI do it. I went and tweaked it. If you've ever written some with AI, right, you have to prompt it, you have to rewrite certain things, you have to look at the overall flow, and man, it's a force multiplier, I can tell you. And writing is not one of my strong suits, but here, though, let's bring back to chemistry, and if you ever worked with, the large language models, but the large language models equivalent, or machine learning applied to science, it can do various things. It can, and I mentioned with so here talking about doing ally research, and it can. Here's a problem looking at alloys that work without using rare earths. So you can see here the Fe, that's iron, right? You can see other things, this cobalt, silicon, right? So it's this robot is looking, this laboratory, and I'm referring to what's in the article. This laboratory is looking for alloys that perform as just as well or better, but looking to use it without rare earths, because rare earths, of course, it's geopolitically, right, with China. And so if we can create alloys that work at the same parameters, like, great, now we don't need to have the rare earths for that, and it's economic, and it's also strategic, right? So if we don't rely on China, and if we are preparing for a war with China, kind of thing. So this is one of our linchpins for that. But the speed that this is doing, and they're talking about it right now. They have one, I think it says 70. Yeah, here we go. Use 70, and this using this robot slash AI lab, they can do 70 alloys, and they're going to scale it up. It's going to be hundreds a day. So it's that's amazing, right? So that you can go to do research like this, and a lot of this, like this sort of, these iterative processes here. So you can see the robot going, mixing things together, and then going and mapping out experiments. And one of the things in the article I thought was interesting is that that when we publish data, we typically publish what works. We don't publish what doesn't work. So when you have AI and other machine learning, and it's learning things, it has to know what doesn't work alongside what works. So a lot of what it's doing here is it's generating data and learning about things that don't work. And myself, when I've done science, science is mostly failure. If you like to win constantly all the time, science is not the career for you, because it's like research is mostly failure, and it's learning what works. And the AI, it thinks differently than humans, but it's impressive. It's impressive how it works, and it can take a lot of strain and a lot of like time and effort away from the humans. And also that means that we as humans, we have to change. We have to change how we work. And even myself, like in my own life, like how I've changed. I used to memorize phone numbers all the time. I know 2 phone numbers, well, besides like 911, but like I know my phone number, I know my wife's phone number. Like I don't have anyone others' phone numbers memorized. So because of all my cell phone, right? So we store information out of our heads. We don't require our memories to actively have that. And the same thing is happening for other things, where we delegate tasks outside of our brains. Like, I know how to long divide, but man, I haven't done long division since like the 5th grade, kind of thing. So why would I do long division? I have a calculator. So we're going to continue to work in tandem with our technology, and it's going to change certain things. And one of the things I mentioned here, like the robots went and they were clean, like between doing experiments, the robots cleaned the inside. Like that's awesome. Can you imagine that? Can you imagine cooking and you never had to clean a dish? We have a dishwasher. If you have a dishwasher, even that's easier. Can you imagine if you had a robot, if you're just cooking and you're done, like, oh, I've cleaned everything up for you. I know that Tesla is kind of looking at something like that, the sort of robot helper in the house, kind of thing. And the same, I think, for the lab. They even have the robot Play-Doh. If you've heard of Play-Doh before, it's the bussing robot. Play-Doh has been brought into the chem lab before to do the glassware dishes kind of thing. So this is interesting to seeing where things go, and how labs are changing, how science is changing, and we don't know where the future has to hold, but I'm fascinated. Maybe you, with my initial thing, like, why would we hire chemists when we can take that money and buy a bunch of robot arms and like that will greatly improve our output and not have to hire someone. The grunt work is going away. Right, a lot of jobs are going to go away if we if we get better robots and AI doing a lot of jobs that are also tedious and dangerous, like mining and things like that, will be outsourced to our technology. So, and AI is not it's not at human intelligence yet. Who knows? I know Elon Musk keeps on talking about how we're getting there, but we're not there yet. And right now, we still have humans interacting, but like I said, our role is going to change, and our role is changing. And this includes in the laboratory and how we do research. And as I've learned, that's how we write grants. And my limited experience using AI is I think with grants, the no news is good news in a way. So, and I checked also in research.gov for my grant, and it's still pending, which is good news, because whenever I've gotten rejection, it's always been quickly. So we'll see. And Google AI even told me that I should hear by the end of summer. So we'll see. So, but I hope you enjoy the article. Hope you think about how your life is changing. If you want to do something goofy, you can watch the music video for Such Great Heights. Like I said, it kind of reminds me of this, and it's kind of cool watching the robots do the work. It's really mesmerizing in a way just to look at this. So, but I hope you enjoy the article, and I hope things are going well. And as I always say, we're not artificial intelligences. We are biological intelligences, and we do not work 24/7. We have other things going on. We are parts of families and friend units, and we also our bodies break down. They require sleep. They require good food, and we require housing. So if you find yourself not having your basics needs being met, or if your mental health is taking a sour turn, or there's other things going on that you feel you need some help, let me know. I am also a biological intelligence, and I'd be happy to help you out with that and get you in the network for people to help. So please keep that in mind, and I hope you're doing well, and I hope you're enjoying the rest of your week. And I know we got a new batch coming soon, and I'll write students that are not doing as well, and I'll write the students that are getting A's too. If you haven't noticed, if you get an A, I always send you a congratulation email for that. So hopefully you'll see that congratulation email then for your A coming up. So, okay, take care then for now. Goodbye.